Hi everyone, we're from Binus University, and in this video we're going to give you a beginner's guide to using containerization technology using Docker. Before we start, let us introduce ourselves. My name is Nicole Minar Widjaja.
My name is Jonathan Theofilus Emmanuel.
And my name is Bryan, Alvis, Xavier, Halim, Chandra.
And without further ado, let us start the presentation. Alright, so first we're going to explain the differences between virtualization and containerization, as these concepts are essential in understanding Docker. Virtualization is the process of dividing a single computer's resources, such as processors, memory, and storage, into multiple virtual machines or VMs using an abstraction layer. Each VM runs a separate operating system and behaves like an independent computer. This is much more resource efficient than allocating a dedicated CPU and server for each task, especially for large processing in data centers and service providers. Other benefits of virtualizations include improved ease of management, ability to maximize server availability by making use of increased redundancy, automated IT management, and faster and easier provisioning. Virtual machines rely on hypervisors, which manages the computer's resources and allocates them into virtual machines, ensuring that there is no disruption among them. There are two types of hypervisors: Type 1 hypervisors, which run on computer hardware and have direct access to the physical resources, making them very efficient. Type 1 hypervisors are usually used for server environments. And Type 2 hypervisors, which run as an application on a host operating system, is suitable for personal desktops. Containerization is a technique of packaging an application along with its dependencies into a single software package, referred to as a container. Containers are portable and can run across various platforms. Containerization allows applications to be developed in multiple environments and allow the virtual machine to launch without needing to boot an operating system. In addition, faulty containers do not affect other containers, making it fault-tolerant, and developers are able to troubleshoot and change an application without disturbing the operating system, hardware, and application services.
Right, now we're going to talk about the Docker itself. Docker is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. The software that hosts the containers is called Docker Engine. It's a tool that is used to automate and the deployment of applications in lightweight containers so that application can work efficiently in different environments in isolation. And now we are going to talk about how it works. At its core, Docker has two concepts, the Docker file and a Docker image. A Docker file contains the set of instructions for building a Docker image, while a Docker image serves as a template for creating Docker containers. It contains all the necessary code, runtime, system tools, libraries, and settings required to run a software application. And now we are going to talk about the advantage and disadvantage. First, the advantage. Docker is very consistent across a wide range of systems, environments, and platforms. It also has high-speed deployment by eliminating redundant installations and configuration that makes deployment fast and easy, while it is also very flexible and scalable, as developers can use any programming language and scale container resource up and down as needed. While the disadvantage is Docker is lightweight, but you pay it with security, and there is a lack of segmentation means that multiple containers can be vulnerable to host system attacks. While it also have a very steep learning curve that developers transitioning from other infrastructure might find Docker easy to begin with, but it gets hard to master. And now the common usage. First of all, it's accelerating app development with Docker containers, scaling application environments, standardized continuous integration and delivery, process for application, isolation of multiple parallel applications on a host system, and enabling a loosely coupled architecture with Docker containers. And here's the key concepts. First of all, images. A Docker image is a read-only portable template used to create containers. It contains the application code, libraries, dependency, and other necessary files, while a container itself are a running instance of an image that operates in an isolated environment. While Dockerfile is the human-readable blueprint or code that builds a Docker image. When a Docker file is used in another machine, that environment is rebuilt. While lastly, Docker Compose is a tool for managing multiple containers application using a single configuration file. Multiple containers may be needed because it is best practice to assign only one task to each container. For example, an application might require multiple interconnected containers, such as a web service, server, database, and cache. Here are the essential Docker commands. Docker ps lists all active containers, while Docker build builds an image from a Docker file in the current directory. Docker pull downloads an image from a registry, while Docker run runs a container from an image. And now we're moving on to the tutorial. I will give it to my friend Theo.
Alright, thank you for the explanation, Bryan and Nicole. Now we'll move on to the tutorial. Alright, now I'm going to show you how to set up Docker on Windows, but if you're using another operating system, such as Linux or macOS, you can follow the instructions provided in the official Docker documentation. So for Windows, first we're going to need either Hyper-V or WSL, and in this tutorial we're going to use WSL or Windows Subsystem for Linux. And to install WSL, first we're going to open the command prompt and we're going to type in the command WSL --install. But I already have it installed in my system, so I'm just going to check the version and confirm if it is installed by using this command WSL-L-V and enter. You can see here that we already have a Linux distro named Ubuntu. Alright. Next, we're going to install Docker Desktop from the official website. We're just going to click this button and press AMD64 as that's the one used for personal desktops. Let's download the installer first. Alright, now that we have the installer here, let's double click on it and install Docker Desktop. Right, the installation has finished. It should open automatically. Should it? Let's open Docker Desktop. Let's accept the terms and agreements and log in using our account. Let's just skip this for now. Alright, now we have Docker Desktop set up. Next, we're going to open Visual Studio Code and we'll head to the Extensions tab and search for the Docker extension for VS Code, which is this one. And I already have it installed, but if you haven't, then you should install this to make it easier for you to containerize your applications. Okay, now that we have everything set up, I'm going to show you how to build your first Docker container. So here I'm going to create a folder called simple node.js application, but you can use your existing application for this. And I'm going to open it in Visual Studio Code, but you can also use your preferred code editor, but I'm going to use VS Code. Yes, I trust the authors, and I'm going to initialize the app by running npm init-y. and I'm creating a source folder, and inside it I'll put index.js and index.html. So inside the index.html, I'm just going to use the HTML5 template, and I'll title it Docker tutorial. And I'm going to display a text of hello world. Let's save that. And for the index.js, we're going to use this code, and what it does is basically it displays our index.html in the local port 3000. This will come in handy later. And what's important for this is that you can see that we're going to use we're using the library Express, and that needs to be installed. So let's just install that first. npm install Express, and we will close that. And lastly, for our application configuration, we'll open package.json, and in the scripts we'll determine the start command to be node src/index.js, because that's where our file index.js is at. Next, we'll create a Docker file without an extension, and inside it we will put the commands for creating the Docker image. So first, we're typing from node 12. This is for using the Node.js official image, but you can use the one that's for your project if it's not Node.js. Then we'll set the working directory by typing workdir to app, which is the directory of our app. Then we'll copy the files using this command, package *.json and /, and we'll specify the installation, the command for installing the dependencies, which is npm install. Next, we'll copy the application files, and we'll set the environment variable for the port, which earlier we determined to be 3000, and we will expose that port. We will expose that port, and lastly we will specify the starting command, which is npm and start. That is it for our Docker file. And lastly, we will need to create a .docker ignore file for the node modules folder. This is because this contains a lot of dependencies for our app, and we do not want to copy this because it's a lot. So what we want is we want to copy the command for installing all of those and not the files themselves. Alright, that is it for the app configuration. Next, we will build the Docker image. So first, we're going to open Docker Desktop. Right, here's Docker Desktop. You can look at your containers here and the images that you've created here. So to build the image, we're going to type in the command docker build -t and then your Docker username. For me, it's Ralph, / the project name. Let's just call it Docker Toots, and then a colon and the tag of your project. Let's just tag it as latest. And lastly, don't forget the dot. Alright, now the image has finished building, and we got this ID here, which is the image ID, which acts as a unique identifier for each image. And next, we're going to create and run a container for this image. We're going to put in the command docker run -p 3000, which is our port, and our username, and the name of the project, which is Docker Toots, and also the tag. Let's just copy it from here and enter. So just for your information, this first port is the local port, and the second port is the container port, but we are using the same one for now. But for your project, you can use different ports for the two of them. Right, we can see that the server is running on localhost 3000, and if we click on that, it'll open it on a browser, and it says hello world here, which is from our index.html file. Right, so now we know that our container is working. We can also see that in the Docker desktop app. And we can use this app to stop and start our container. And we can also delete it here. So this app is for managing our containers and images. Alright, now that the image and the container are working properly, if we're going to use this image on another machine, then we'll need to push it to a registry, and in this case, we're going to use Docker Hub. So in order to push it to Docker Hub, first we're going to need to log in into our account in Docker, and then we'll run the command docker push and our username / our project name, which is docker toots, and the tag, which is latest. Alright, the image has been pushed to Docker Hub, but to make sure, let's open Docker Hub and check if the repository is there. Docker Hub. Repositories. Yeah, it's here. Alright, then it has worked. And for now, let's stop the container. Let's stop the container and delete it. And let's also delete the image to simulate another machine. So let's pretend that we're on another machine. So let's close this. We don't need this anymore. Right? Let's pretend we're on another machine, and we're going to pull this image. So in order to pull it, first we need to run docker login to log into our account. Then we're going to run docker pull username / project name, and then the tag, which is latest, and we'll press enter. Right, so we're pulling it from the Adolf Docker Tools repository, and let's check our Docker Hub. It's here again. As you can see, we have deleted it before, but it's here again. Just to try one more time, let's copy the command and paste it here. And it has appeared again. Right, now lastly, in order to run this image, we're just going to use the command from before, which is docker run -p 3000 username / project name, and then the tag. And here the container has reappeared, and we can open it again in localhost 3000. This is the one from before. If you reopen it, it's here again. And if we end the container, if we pause it and we refresh it, it should not be here anymore. Right. Alright, so that is it on how to build your first Docker container. And I would also like to tell you that you can also use the Docker extension that we have installed earlier to do the commands that I mentioned. So pull, push, tag, and run. But I wanted to show you how to use the commands themselves so that you can do it manually. But you can also use that. And here are the references that we used. And that is it for our presentation on virtualization, containerization, and Docker, as well as how to use Docker. We hope that we have helped you understand Docker better and grasp the concept of containerization. Thank you all for listening. Goodbye!